Alrighty, let's get started. So, first of all, any questions about anything so far? Anything we've done? Any of the assignments? Anything at all? We're good? Okay. So, what I am going to tell you today is a little something about repetition or loops, and it goes like this. All right, so first of all, if you actually go to the Wednesday, there's a couple of links in there. There's a repetition, which has some examples of, different kinds of loops, right? So I'll just get this started. So let's say, for example, I'm going to start you with a for loop. Okay? So a for loop is a way to repeat something a bunch of times, right? Let's say I want to do print hi, right? And I want to do it many times, right? So instead of me going in there and doing this 5 times, right? Let me just run it. And this is 6, 14, 2017. Okay, so if I run this thing, from what you've learned, there you go, it shows 5 times. Okay, so what I'm going to do is, instead of repeating the same thing 5 times, I am going to just comment this piece out. And I'm going to do this. I'm going to say for I in range from 0 to, and by the way, notice how it guides me through this. So there's options. There's a way for you to tell it just how many times to do it. I can just tell it, okay, do it 5 times. But I'm going to stick to the format that is used in most other programming languages, which is you want to tell it where it starts, you want to tell it, and it guides you here. So it tells you, this is the first one. The first one is a start. The second one is going to be the stop. The stop is going to be 5. And then the third one is going to be the step. The step is the increment or decrement, whatever you want to call it. Okay? So if I do this, and I just grab this thing here, copy one of these, and I put them right in there, and I run my program, you're going to see that it does the same exact thing, right? There's 5 highs. All right? So this is my start, stop, step. That's the format of a for loop. Okay? What happens is it changes the values of I, and I is just a variable that I made up. Okay? So it will change the values of I from 0 to 1 less than 5 in increments of 1. So instead of a high in here, I'm just going to go I equals, so you can see it, I, and I'm going to run this again. And 0, 1, 2, 3, 4, right? So I'm going to put a little comment in there. So it's I is equal to 0, 1, 2, 3, 4. It does not go all the way to the 5, right? It goes 1 less than 5 because it starts at 0. It still happens 5 times. Okay? The increment does not have to be 1, right? So let me go in there. I'm going to do another one. I'm just going to grab this thing. And I'm going to tell it, all right, go from 0 to 5 in increments of 2, right? And I'm going to go run this thing. Let me just put a little separator in there. Print. All right, I'm going to run it again. All right, so it goes 0, 0 to 4. So what is it doing? It is going in increments of 2, okay? So far, so good? Pretty basic. Okay, it does not have to be a positive increment. I can tell it to go backwards. So let's say I'm going to go do this. I'm going to tell it to start at 5. Start at 5. I'm going to tell it to go to 0, and I'm going to tell it to go backwards. Okay? So now when I run this thing, right? Then I'll go 5, 3, 2, 1, right? It does not go to the It doesn't go to the 0. Remember, it never gets all the way to the end. So this one here is 5, 4, 3, 2, 1. Right? It still happens 5 times. So the loop changes the value of this variable based on these sets of values for the range. Okay? Any questions about any of this so far?
Do we always type for I or?
Okay, so the question is, do we always have to use the I variable? Nope. I can go and call this thing index. All right, just make sure that this here is called index. All right, I'm going to label it as index 2. All right, and if I run it, all right, you'll see that's the same thing. So the variable that I choose, it really doesn't matter. It's arbitrary. I choose it. I is just a very common one. It's like an iterator or index. Or it's a very common one, but you could call it whatever you want. Okay, so this one is index changes. Okay, good question. Any other questions? Okay, so this is just the variable I make up. It can go forward, it can go backwards, right? It's depending on how you tell it. Okay, you have a start, stop, step. So this is one way to do this. Okay, another way to do this is if you were, well, I'll just leave it like that. So this is a for loop. So what do we use a for loop for? So if you know where I or index starts, where it ends, and what is the step, that's a good candidate for a for loop, right? You know how many times it's going to happen, you write a for loop for it. Okay? Now, there's another way to do this, and that is using a while. Okay? So I'm going to do the same exact thing that I did. Now I'm going to do a while. So this is a while loop. Okay? So I'm going to go in there, and I'm going to rewrite this piece here. Right? The same one that I had. So I'm going to go, all right, first I have to tell it where I starts outside of the loop. So I'll say I is equal to 0. Now I'm going to tell it while I is less than 5. And then in here I'm going to tell it I is equal to I plus 1. Right? So this is what happens in the for loop actually. You're giving it some initial value. You're telling it go on while you're less than this one. And then you're telling it increase your value by plus 1 every time. It doesn't have to be plus 1. It could be minus 1. It could be plus 2. Okay? So I'm going to go in there. I'm going to throw that same print. And what I'm going to do is I'm going to just turn off this piece of code because I don't want to see it loop through these every time. So turn this off. So in here I'm going to throw a print. And I'm just going to add like a little while in there so you know that it's in the while loop. Okay, I'm going to run it. Whoops. Run it. And there you go. 0, 1, 2, 3, 4. Same exact thing as the for loop. Okay? And just like the for loop, I can go backwards. Right? Alright, go backwards. So I'm going to go paste this thing here. I have to tell it where it starts again because otherwise it will assume the old value of I. So I was 4, and if I try to do this loop again without resetting it, it won't work the way I want it. Okay? So what I'm going to do is I'm restarting my value of I to 0, same thing, and I'm going to go backwards now. Right? So I'm going to run it. And whoops. And that's an example of a never-ending loop. I messed it up. Right? So why is it going backwards forever? Because it's still less than 5, right? All these negative numbers are less than 5. So all I'm going to do is I'm going to kill this thing. All right? You do Control-C to stop this thing. And I accidentally created a never-ending loop. Okay? How am I going to fix this? Any ideas? How do I fix this loop so I prevent this stuff from happening?
You give it a range while I is less than 5 and...
Without a range. I just need to change this piece right here. Huh? Nope. No, not an end. I just have to change this piece actually. What do I change this to? How about I just flip it to greater than? Right? So it's going to start at 0. It's going to go on while it's greater than 5. Well, no, that's not right. So let me go do this. I'm going to start it at 5. I'm going to tell it go on while it's greater than 0, and then it's going to go backwards. Right? So this is, let's have a look at it. All right, so this is the second one. I told it start at 5, go on while you're bigger than 0, and then go backwards. Okay, so the while is a little bit more involved. You have to think a little bit more, versus the for, you just, it's pretty straightforward. Okay, so generally speaking, you would not be doing this kind of a stuff with a while loop because it's easier to do it with a for loop. Okay, but just showing you that there is a way for you to do it either way, right? While or a for. So you might ask, well, why are we even bothering with a while loop? Well, one example was if we have, remember how we had input validation? And let me go in there and fix it. All right, so let's say I had my age is equal to int input. Please enter age between 0 to 123, right? And in here, we had before if my age is less than 0 or my age is bigger than 123, I'm going to tell them print invalid age, and then I'm going to do this thing again. Right? And if I do this, and I mess it up more than once, let's say I give it a bad age, right? That's the first input. And then I'm going to go, it tells me invalid age. I'm going to go in there, I'm going to give it, again, wrong input. That's it. It only does it one time, which is normal because the if only checks one time. Okay, what I'm going to do is I'm just going to flip this thing to a while, run it again, and I'm going to go -9, -9, -9, really big number, right? It stays in there, it's stuck in the while loop indefinitely until you get it right, which is what I want. Okay, so if I give it a good age, 7, stops. It finally accepted the value that I gave it. So this is an example of how you do input validation with a while loop. That's one of the purposes of a while loop. Okay, you basically treat it like an if that happens over and over and over and over until something's true. Okay, unlike the for loop, you can add logical operators and you can add multiple conditions in there. So it's a lot more powerful than a for loop. So again, remember, the for loop is, you know where it starts, you know where it ends, and you know the increment or the step. Okay? For the while loop, we could do the same thing. It's just a little bit longer, so why would you? Right? But it's very useful if you want to do input validation. Okay? So that is some of the basics of a while loop. Okay? So you can also have a loop. So this is just the basic scenarios where we could use loops. Okay, I'm going to turn this piece off too, because I don't want to keep seeing it. Okay, you could have a loop that happens as many times as the user wants to. Right? So all I got to do is grab one of these first ones. Right? Let me go with the for loop. Right? And I'm going to delete these highs here because I don't want to see them anymore. Okay? So what I'm going to do is I'm going to change this piece right here. Right? The final where it ends. Right? So I can just say, well, let's just make it easy. So remember that you had your start, stop, step, right? So I'm going to go in there. I'm going to ask what the stop value is. So stop is equal to int input, and ask the user how many times do you want to repeat. All right? And then they're going to enter some value, and that value is going to determine how many times the loop happens. Right? So if they entered, let's say 3 here, the values of this thing should be 0, 1, 2. Right? Let's test it. Run it. All right, I want this to happen 3 times, 0, 1, 2. Okay? Any questions so far? Okay, so that's how you can do this with a for loop, and you could do the same thing with a while loop. So I'm gonna go in there, grab one of my while loops. All right, let's get that first one here. Okay, throw it in here, and all I'm gonna do is I'm gonna change this thing here to stop. Right, I'm gonna run it again, and I run it, let's say, 10 times. And it goes from 0 to 9. Okay? Any questions? Okay, so that's an example of a loop that happens as many times as the user wants to. Again, if you know how many times something is going to happen, you do it with a for loop. It's just a better practice to do it that way. It's cleaner code, it's easier to understand. Why would you waste 1, 2, 3, 4? You basically have 1, 2 extra lines when you can just do the whole thing in one line. Okay? So, that's one thing. And let me turn this piece off now. Okay, so that's one thing. All right, so now let me go back to this. And now I'm going to show you a loop that can go on forever. So let's say I want a loop that goes on until, or it goes on forever until the user enters, I don't know, negative 999. Okay? So I'm going to go in there, and there's a couple of ways to do it. First, I'm going to show you with the a never-ending loop. So let's say I'm going to do while true, right? Remember, true is just the reserved word that's in the language. It's a Boolean data type. I don't have to type true. I can do something like 3 is less than 4, which is always true. But why would I do that? I'm just going to say true, okay? And then I'm just going to do a print hi, so you can see that this thing goes on forever. All right, there it is. All right, never-ending loop. I'm going to go in there. I'm going to kill it. Okay, Control C to stop it. Okay, so how do I stop this thing? Well, instead of a hi, why don't I do this? I'm going to say, let's say input, or int input, because I said it's going to end at negative 999. Int input, and I'll tell the user, enter negative 999 to stop the loop. Okay, and I'm just going to make up some variable. I don't know. Let's say stop, or let's say stop. Okay. All right. So if my stop is equal to negative 999, I want to stop this loop, right? So I'm going to go in there. By the way, bless you. If I run this, oops, forgot my parentheses. Run it again. All right. If I run it like this. Let me just kill it real quick so that I can add my little colon at the end. All right. Okay, so negative 999 to stop the loop, 3, negative 9, whatever number I type, it goes on forever until I enter a negative 999, and it still doesn't stop because I haven't told it. So I'm going to go in there. I'm going to add an if. If my stop value is equal to negative 999, what I'm going to do is break it. So break stops the loop here, or stops or exits if you want to call it. Okay, so let's test, run it. So 1, negative or positive 999, negative 999. It stops, right? So you can see that it stops when you enter a negative 999. Any questions? So far, so good? All right. Now let me, mess with you a little more. So let's go in there. I'm going to do a print hi. All right. When will this value show? Okay, but for which values will this show? Let's check. I'm going to run it, and I'm going to go, all right, give it a 1. Shows the high, right? Give it a -1. Shows the high. Give it a -999. Oops, not there yet. So 999. No. Give it a -999. It doesn't show, right? So the fact that it doesn't show confirms what I just said here. So as soon as you encounter a break, you exit the loop. You could have a bunch of other things after it, but when you encounter that break, you're out. Okay? You don't do any of the things under it. Okay? So far so good? All right. There's another one. There's another way to do this. So what I'm going to do is I'm going to copy this whole thing here, and I'm going to rewrite it without a break. Okay? So I'm going to go in there. I'm going to say, okay, first I'm going to make sure that my stop value is equal to some good value, whatever, 1. And in here I'm going to say while stop is not equal to -999, right? Is it not equal to -99 initially? Yeah. So this thing is true for anything that is not -999. And if I go in there and I do your print high, you're going to see that you got a never-ending loop again. Okay? So let me go kill the loop. I'm going to go in there. I'm going to do the same thing. Get my input. And by the way, if you notice, if you just have a print, this thing goes on forever without any interruption. If you want to stop the loop as you're going through it every time, you need the interruption, the way you're going to do that is with an input, right? I'm going to run it again. So first time I go through the loop, it stops, it asks me for a value, then I'm going to go give it different values, and then finally I'm going to give it the stop value, and then it ends. Okay, so just another way to do the same thing that I did on top. And like I told you already, there's many ways to do the same thing. There's not just, oh, I'm going to do it this way and that's all there is. Just use your brain, think about things, and there's many, many different ways to do this. Okay? Any questions? So far, so good? All right. So, what else do I want to tell you? All right. So I'm going to turn this piece off. Or actually, I'm going to put, yeah, that one's going to be off too. Let's see what else I want to tell you. So I got the two. So, and these things that I'm just showing you, they're you know, in the lecture notes that I did. I already showed you the input validation, right? The input validation was you assume that the user enters some garbage value, and then you check to see if it is a garbage value. If it is a garbage value, then you ask them for another one. Okay? All right. And this one here, I'm just going to copy it because I don't want to type it. This one is how you would validate input of anything, right? So remember, actually, let me just paste this here. I'm going to turn it off for a second. And I'm going to go back to my, where's my input validation? This one, right? So let's go back to my input validation right here. And I'm going to break it for you. So this piece of loop, this loop here is going to work fine if I give it numbers, right? So if I give it -1, it works like a charm. If I give it, you know, really big number, it works great. If I give it a good number, it stops. But what if I decided to enter this? Nope, doesn't like that, right? The error is you can't enter this into an integer input, right? So it's expecting an input to be an integer. You give it a string. That's the error, value error. Okay, let me go break it again. So I'm going to run this again, and this time I'm going to give it a 3.14, right? No, doesn't like that either. It's expecting an integer input. You gave it a float. No good. Okay, so how am I going to fix this? This is like a Mickey Mouse input validation because they are supposed to know what to enter, and otherwise the program breaks. No good. Okay, so watch how that gets fixed. So I'm going to go back here. Let me copy this. Input validation. And that's this here. So input validation with a while loop handles value error, right? This is the value error. So these error messages that we're getting, we're going to handle them. How we're going to handle them? Well, it goes like this. I'm going to have a loop, a while true loop, and parentheses are optional. Let me get rid of them. So I'm going to, in this loop that goes on forever, I'm going to try, that's a reserved word in Python, to enter an integer. Okay? If it's successful, we're just going to stop the loop, right? And I'm going to show you, I can show you print num guessed. Hopefully it works. All right. All right. Let's see if this works first for good value. So I'm going to run it. And enter any number to quit. That's this message here. I'm going to give it a 1. Okay, no problem. All right. Now what I'm going to do is I'm going to run it again. And I'm going to go and give it a string. So what did it do? It tried to get that input. It failed. But instead of giving me that red message which I encountered before, I told Python what to do in the event of that message. Right? So instead of doing value error, red text, meaningless message, I can change the message to something that's actually meaningful. I can tell them, all right, you did not enter maybe an integer. Right? You want to be a little more specific with your error messages, right? Because if you don't enter an integer, you will crash. Run it again. All right? Enter any number to quit. I'm going to give it a 3.14, a float. Nope, you did not enter an integer. Let's try it again. Give it a string. Nope, doesn't like it. Give it a number. Okay. Now let's tweak this thing a little bit so that we have a bad value. So let's say I'm going to go this. I'm going to get this thing here. And I'm going to ask for a user input ahead of time, right? That's like a real situation. So I'm asking for a number to quit. And let's say I'm going to change this thing to age, right? Age, the good old age, right? So enter age, integer age between 1 to 123, okay? What I'm going to do is I'm going to change this here, instead of a while true, I'm going to change it to, just like I have my input validation up here, where was that thing? This. Right? I'm just going to change it to this that I had before. Okay? So I'm going to just replace this while true with while my age is less than 0 or my age is bigger than 123. That loop's going to go on forever. And a lot of times, for testing purposes, I like to just turn this off and just give it a bad value, right? You will see a lot of that stuff even in these examples here. Like right here, that's what we're assuming. We're assuming that the user entered a garbage value. So I'm going to go in there and just for our sake, I'll leave it like this. Okay, so I'll run it. And I'm going to go in there and first of all, I'm going to give it a good value. Right? If I give it like 12, no problem, right? That's a good value. We don't even have to, do anything with it, okay? But keep in mind that if I went in there and I tried to ask for this before the loop, I could encounter an error. I'm not handling the error, this kind of an error yet, okay? That's handled inside of the loop, all right? So let me go in there. I'm going to say, all right, my age is -1, right? So it's a bad one to begin with. I'm not going to risk the user to enter anything in here. I'm just going to assume it's garbage. Okay, run it. All right, enter a number to quit. It's already in the loop because it's a bad value. I'm going to give it 12, and it stops. Okay, it stops because this is no longer true. We can just stop the loop. Okay. I'm going to run it again. And I'm going to give it Negative. Negative 9 repeats. Whoops. Less than 0. While age is less than 0. Or age is bigger than 23. If it's less than 0, that stumbles me, because the loop is supposed to go on while the age is less than 0, right? And I gave it a less than 0. Let's fix this. I'm going to make this true again. And I'm going to add if my age is less than 0 or my age is bigger than 123, that's when I'm going to break it. No. If my age is less than 0. No, I don't want to break it. If that's true, I'm going to continue. And otherwise, I'm going to break it. Okay? So what continue does is it actually goes back to the beginning of the loop. All right, let's test it again. Even though it should have worked that first time, I got to go play around with this thing. It's just, I'm not realizing why it's doing it. So let's go negative 9. There we go. So I fixed it. All right, so if I give it a negative value, it goes continue. So what is the meaning of continue? Continue makes the loop resume from the beginning. Okay? And what you just saw is a real world situation. You expect it to work one way, but for some weird reason, Python is not working with you. It's not cooperating. Sometimes it happens. But what are you going to do? You're going to work around. You're going to make you're going to create a solution that works in this particular case, which is what I just did. Okay? So if I give it a negative 1, it repeats, makes the loop resume from the beginning. And by the beginning, I mean all the way at the top. Okay? I'm going to run it again. Actually, just give it a big value. It repeats forever. And if I give it a good value, it should stop. Okay, so this piece now I tested, it works. Now let's go back and give it non-integer value. So I'm going to go ahead and give it 3.14. Now it's going to give me this message. You did not enter an integer. Let's try it again. All right, I'm going to give it a string. No good. I'm going to give it a good value, and then it stops. Okay? Any questions? So that means now I don't even have to have this here. I can just turn this off. Right? Because it's a while true, it goes on forever no matter what. Right? So that's a real input validation. Right? In my opinion, it should have worked before too. I don't know why it wasn't breaking it. All right, I'll figure it out later. Any questions so far? This is input validation. All right. So I'm going to go in there. I'm going to turn off. Actually, let me just run it one more time just to make sure after I deleted things. So I give it a negative. That's no good. I give it a really big number. That's no good. I give it a string. That's no good. I give it a float. That's no good. I finally give it a good value, and then it stops. I finally accepted the good value. Now the program can move on and do things with it. All right. So these are some of the practical applications of a while loop, okay? And there's more. Let's say, for example, I'm going to turn this piece off because I don't want to deal with it again. Let's say I want the user to enter, I don't know, 5 numbers. All right, let's do this first of all. Actually, ask the user how many numbers they want to enter, and then find the sum of all the numbers that were entered. Okay? So, in order to do this, that's an example of accumulation. And by the way, accumulation is what was happening right here. right? The value of I starts at 0, and then then accumulates values into itself in increments of 1. So it goes 0, 1, 2, 3, right? It accumulates all the values that were I into the I itself. So what I'm going to do now is I'm just going to make some variable sum. I'm going to make it equal to 0. Always want to start at 0, right? Because otherwise it's not going to add up to the right amount of numbers that you want. Okay, so in here I'm going to ask the user, let's say stop is equal to int input how many numbers do you want to enter. Okay, and I'm going to make a for loop, right? Because if I know how many times the thing is going to happen, I'm using a for loop because it's going to save me time. So for I in range from 0 to stop in increments of 1, always 0, always 1, when you're going to have a loop that happens as many times as the user wants to, right? So a loop that happens as many times as the user wants to. Okay? So what I'm going to do is in here I'm going to ask them to enter a value. So value is equal to, let's say we're going to stick with integers. Input, please enter an integer. And I'm not going to bother with input validation because I don't want to throw all these extra things in there for now. I'm just going to keep it simple. But you could do this kind of a loop also if you wanted to. Okay? But let's keep it simple so that you understand what accumulation is. So accumulation. Okay? So we're going to be adding a bunch of values into the variable sum. So, and it goes like this. Sum, oops, capital S, sum is equal to sum plus value. Right? That's one way to write it. Another way to write this is sum plus equals value. That's the shorthand. Which one you write, it's up to you. I kind of like this now because I'm comfortable with it. But when I remember when I was first learning things, this kind of makes a little more sense. You're telling it, okay, add this value to your old value. Okay? And this one here tells it the same exact thing. You're increasing this by this much. Okay? So, and I'm going to show you the sum after. So print sum equals sum. Okay? I'm going to run it and hope for the best. So I want 3 numbers. First number is 1, second one is 2, third one is 3. What's the sum of these? 1 plus 2 is 3, plus 3 is 6. That's what I got. Okay? How would I find the average? Average is just print sum, average is equal to your sum divided by what? Stop. Or if you want, why don't we call this many, right? Many. This is going to be many. So sum by how many numbers you had. That's your average. So let's run it. Same thing again. I want 3 numbers. 1, 2, 3. All right. 6 divided by 3 is 2. That's my average. Okay? So far so good?
No. You're going a little too fast for me.
Okay. Question. What's your question?
Just to round off the last two, how do you do that again?
What do you mean?
So if I have, say, 2.9999,
How do you?
I want it to be 2.99.
Okay, so I would do average modulus. So the question is, how do I round this thing to 2 decimals? Percent point 2f, and then this here is percent in front of the formula. All right, I run it again, and I'm gonna do three numbers, 4, 5, 6. Now it shows you 2 decimals. Okay. Any other questions? So I'm starting sum at a certain value. I'm asking the user how many numbers they want to enter. That's how many times the loop is going to happen. Then inside of the loop, I'm asking them to enter values. That's this piece here, right? They enter a bunch of values. And then I'm adding each value into the sum. right? So add each value into the old value of sum, okay? And then the above is also, so the above can be rewritten as this, okay? So whether I do it this way or I do it this way, it should give you the same exact thing. So I want 3, I want 4, 5, 6, same thing. Okay? Any questions? Yes, sir.
Just wondering, the value of I in the for loop to start off the loop, is that initialized somewhere?
Right here.
Oh,
So the question is, what is the value of I initialized somewhere? It is by default initialized to this whatever this is, and this doesn't have to be 0, right? It's 0. It starts at 0, and I increment it by 1 only in the case where I have a loop that happens as many times as the user wants to, right? If I want this thing to go from 10 to 20 in increments of 2, that's what the value of I is going to be. Okay, so yeah, value of I is initialized to this, and it is changed by +1 every time until it hits 1 less than this value. Okay? Any other questions? All right, so as you can see, things are getting a little more complicated, and that's another example that I had in there. Okay, and since you just asked, about the value of I, that's a nested loop. Let's not go there. So let me just go back again. Another example of a for loop. I'm just going to turn off this just for a second so that I can show you, step back just for a little bit and illustrate, right? So the value of I is initialized to 1, right? If I did it this way, right, and if I run it, I'm just going to show you I is equal to %d. Why is it a %e? Let me just turn this off. %i, that's another way to do it. %d is for an integer. I think %i is also an integer. Let's just give it a shot, see if it works. There you go, 1, 2, 3, 4, 5, right? So I starts at 1, right, and it ends at 1 less than 5, okay? I can go and tell it, okay, we'll start at 10 and go to 20, but then go in steps of 2, okay? So what are going to be the values of, what are going to be the values of I? Yeah, let's see if we can figure this out. What do you think is going to be? I is equal to what? 10, 12, 14, 16, 18. Does it go to 20? No, it does not. It never goes all the way to the end. It will go to the end minus this value, right? So let's double check, run it. 10, 12, 14, 16, 18, right? Let's do another one. I'm going to grab this thing. I'm just going to paste it and turn this piece off. So this one it's initialized to 10. Let's say I change this thing to 3. Right? What are the values of I going to be then? 10, then what? 13, then 16, then 19, and then it will stop, hopefully, right? That's my prediction. So it would never go all the way to the end. It will try to get us close to this, but not become equal to it or exceed it, right? Run it, and there you go. Right? Convinced? Any questions? All right. So I'm going to turn off this piece too. And I'm going to go back to my accumulation example. All right. So going back to the accumulation, so I'll find the sum and average of all the numbers that were entered. Okay? So that's one practical application. Okay? I'm going to do more. I'm going to do something else. So let me see if this works. All right, good. All right, so there's also nested loops. I'm not going to get into nested loops just now, but basically you could have, what the hell, I'll show you. So here, I will show you this piece here, just to blow your mind. All right, so this is an example of nested loop, right? One loop inside of another loop, okay? And it goes like this. Did I copy the right thing? Oops, I'm missing the F. Okay, so how does this go? I have a variable I, which goes from 1 to 5, right? 1, 2, 3, 4, 5, and it doesn't get to the 6. Then I have another variable j, which is going to go 1, 2, 3, right? It does not get to the 4. All this other stuff here is just so that I format the output the right way. Let me just show you what it looks like. Okay, don't worry about it too much, right? So the bottom line is, just ignore this for a second, right? It's just so that I format the output the way you're looking at it. The moral of the story is, this loop here makes this loop happen as many times as this one happens. So basically, look at the values of I. I goes 1, 2, 3, 4, 5, right? That's what this one is. Okay? But every time this one happens, the inner loop happens another 3 times, which is this one here. J is equal to 1, J is equal to 2, J is equal to 3. So this loop makes this one repeat many times. Questions? This kind of stuff is used like if you're doing differential equations and you're doing, let's say, matrices. If you're doing matrix multiplication and matrix, transposing matrices and all kinds of different things like that, this comes in handy. Not just that, but you're going to have sometimes triple nested loops, which gets crazy. Don't worry, you're not going to have to do, well, there are going to be a couple of more challenging assignments here where you're going to have to do some nested loops, but they're an exception to the normal. I'm not going to go crazy with nested loops. Okay? But now you know there is a such thing as a nested loop, and I'm just going to copy this output so that you know what it is. So that's my output. All right? Actually, no, I'm not going to leave it there. I'm going to take it out because I want to turn this whole thing off. And I'm going to tell you here, just look at the class page for what the output of the below looks like. And the easiest thing to do is when you download this lecture, which I'm going to post, just go in there and turn off the green stuff, run the thing so that you see how it works. Okay? But let's not get distracted with this crazy stuff with the nested loops, because it is a little bit more advanced. We're just barely learning the loops. Okay, when we get a little bit more comfortable with loops, that's when I'm going to throw in some more of these in there. Okay, all right. So that's basically the intro to loops. Let's see if I have a conversion table. I have a tuition table, sum of positive and negative numbers. All right, I'm going to show you how to find smallest, largest, sum, and average. Well, I already showed you how to do sum and average. Now I'm going to show you a little bit more, right? Because I'm going to show it to you one time today, and I'm going to show it to you again on Friday. Hopefully it sinks in. So, let's say I want the user to enter, I don't know, as many numbers as they want. So this is a different one from the loop that I had before. So this loop here was ask the user how many numbers they want to enter in advance, and that's how many times the loop happens. Okay, this one is going to be different. I want the user to enter numbers forever until they enter negative 999. Right? So I'm going to go in there and I'm going to do this the whole business with the sum. Oh, and I'm looking for, again, find sum, average, but this time I'm also going to look for the minimum, I just call it min and max values. What's the smallest thing they entered? What's the biggest thing they entered? All right, so these are, again, things that you should be able to do. You have to know these things, okay? And guess what? I'm going to be asking you to do them over and over and over. There's going to be like probably 5 or 6 different assignments where I'm going to ask you, find the min and the max. All right, now do it this way. So one time you're going to do it, the user enters as many numbers as they want. The second time is they tell you how many numbers they want in advance. Third one is going to be, oh, read it from a file. Fourth one is going to be, oh, read it from a list. So it'll be the same kind of problem with different concepts thrown in there. But I expect you to know how to find the sum, the average, the min, and the max. When we get to functions, I'm also going to tell you, okay, write a function that does the sum, write a function that does an average, a function that does the min and the max. The final exam, guess what it's going to be? This stuff. All right, so you better get it right. Okay? And I'm sure you will, because if you do it like 5, 6 times and you don't get it, we got a problem. Okay? All right, so let's do this again. So I'm going to say sum is equal to 0, right? When I'm dealing with accumulation, we're going to be summing up values. I want to start this thing at 0, right? If I started it at like 100, obviously my sum of the numbers is going to be whatever they entered plus 100. I don't want that. Okay, so sum starts at 0. I'm going to have a while true this time, right? Inside there, I'm going to have, all right, num is equal to, let's stick with integers. Input, please enter a number. Okay? And then if that number is equal to -999, I'm going to break the loop. All right? Stop it right there. But if it isn't, what I'm going to do is I'm going to add it, plus equals num, right? Also known as sum is equal to sum plus num, right? So I'm writing it the other way, okay? Because it's shorter. And then what else do I have to do? So I showed you, but for this one, so remember in the other example that we just did here, to calculate my average, I figured out, oh, it's going to be sum divided by many, but the user tells you what is many in advance, right? We don't know what many is in here. So how am I going to figure out how many numbers they entered? How about if I just make a variable called many right here? I'm going to start that thing at a 0, 2, just like my sum. Okay? And if they didn't enter a -999, in fact, why don't I call it count? Right? I am going to count what they entered. So count is equal to count plus 1. Right? Also known as count plus equals 1. Either way it works fine. Okay? So I'm going to count every non-999 number that was entered. That's what this is. Why am I doing this? So that I can figure out the average. I need to figure out average by dividing sum by count. Okay? So, let's see. I'm going to say print you entered count numbers, and I'm going to tell you print the sum is sum, and print the average is sum divided by count. And let's try it. Run it. Please enter a number. 1, 2, 3. Now I'm going to give it a -999. So it stops, right? It stops at a -999. And the sum is 6. The average is 2. Convinced? Any questions? Okay. So that is basically just doing the sum that we did before without knowing in advance how many numbers the user is going to enter. We're going to count them. And by the way, this idea of counting things comes in all over the place. I mean, all the time. Believe me, almost every program you're going to have to write is going to have to count something. Because you're not going to know in advance what it is. Maybe you want to read a bunch of numbers from a file and then figure out the average. You don't know how many numbers are in the file. You're going to have to count them, right? So count comes in all the time. All right. So you should know how to count. But now that we figured out the average and the sum, let's figure out how to do the min and the max. All right. So there is an algorithm to finding the min and the max, right? And it goes like this. So I'm going to say here, algorithm to find min, right? I'm going to go with min because max is going to be almost exactly, well, pretty much the same thing. Okay, so first thing that you want to do is you want to make a variable min equal to the first number entered. Okay, the second thing is compare min to every other number after the first number. Okay, and then third is if any other number is smaller than min, make min equal to it. Right? So let's say I have, I don't know, 10, 1, 3, 4, something like that, right? So what I'm going to do is I'm going to say, okay, min is equal to 10 initially. That's the first one, right? That's the step 1. Then I'm going to check to see if min is, if any of these other numbers, so let's say if 1 is less than min, then I'm going to say min is equal to 1, okay? And then it's going to go to the next one. If 3 is less than min, then min is equal to 3, right? And then if 4 is less than min, then min is equal to 4. So what is it going to do? Initially it's equal to 10. Right? Then it goes and then you go and you compare it to the next number over. Okay? Is 1 less than 10? Yeah, it is. So now min is 1. Then we're going to go and compare it to the next number. Is 3 less than 1? Nope, stays as 1. Then go to the next number. Is 4 less than 1? Nope, stays as 1. So I go through this, I make min equal to the first number, then compare it to all the other numbers. If any other number is smaller, that's your new min. That's the algorithm. Okay? And I like to write things kind of like this in like a really simple format so that I know what happens. Later on, when you start doing data mining and all kinds of other crazy things, you want to have like a basic concept of how I'm going to do things before you actually write the code. Okay? All right. So make a variable min equal to the first number entered. Let's go in here. So let me, I'm going to copy this, and actually let me get this one here. Copy this, and I am going to go right here after the sum. Okay, so my question to you is, this sounds great, but how do I know what's the first number? So my question is, how do I know it is the first number? What's going to tell me it's the first number? You're going to enter a whole bunch of numbers, right? How do you know it's the first one? Count, right? Okay, so count tells you. What is the value of count for the first number? That one's very hard. 1, right? It starts at 0, and you add 1 for the first number, so it's going to be 1 for the first number. So if count is equal to 1, right? True for the first number entered. Right? What did I say? I'm going to say min. Let's go lowercase min, uppercase. Min is equal to what? Which one is the number? Num. the variable num. Right? So that's the first value they entered. Right? Let's say they entered, the values that they're going to enter is 10, 1, 3, 4. Right? So at this point, min is equal to 10. Okay?
And why are they entering those numbers? 10, 1,
They could be any numbers, but I'm just going with these.
Oh, yeah.
Yeah, just an example. Right? So let's suppose the user is going to enter these values. So it's going to be 10, 1, 3, and then it's going to go negative 999, right? It stops at this. When they enter negative 999, we hit the brake. We're not going to do any of this business. But up to that point, right, we're going to go min is equal to 10, right, initially. Okay, so that's the first one. Make a variable min equal to the first number that was entered. How do we know it's the first number? Count tells you when count is equal to 1, that's the first number, so make min equal to that number, whatever that they entered, which is a 10. Okay? All right, next one. Compare min to every other number after the first number, right? So I had an if here, right? If count is equal to this, that's the first number. How do I identify all the other numbers, basically? If I just said else, right? This automatically happens for every other number after the first, correct? So if it's the first number, you make min equal to the first number that the user entered. Otherwise, else means the count is not equal to 1, right? Which is count is 2, count is 3, count is 4, count is a million, right? Anything other than 1. So after the 1, that's the else, right? Which happens automatically for every other number after the first number. What I'm going to do is I'm going to compare min to every other number after the first number. So I just go if any other number is less than min, and I'm going to put little comments in there. So if any other number is less than min, then I say min is equal to that number, right? Or this is the new min. Does that make sense? And that was the other step that I had. So if any other number is smaller than min, make min equal to it. Let me put a little comment in there, right here. All right. So if any other number is smaller than min, make min equal to that number. Okay? Does that make sense? If it doesn't, you're going to have to do it again and again until it clicks. Okay? So, let's see if it works. Print the smallest value is min. Alright? Let's see. So, remember, my prediction was that if I enter these values, the minimum value should be this one. Because we're not including the negative 999 because we have a break. Okay, so run it. Keep your fingers crossed. So I'm going to go, what did I say? 10, 1, 3, 4, negative 999, and the smallest value is 1. Right? Maybe you don't believe me. Let's put it in a different order. So I'm going to run it again. Alright, I'm going to do 10, 10, 3, 1, 4, and then negative 999, and it still figures out the smallest value is 1. Okay, so it doesn't matter in what order I put these things, it will go through them, it will make min equal to the first number, then it will compare all these other numbers to the min, and if any of these numbers are less than min, make min equal to that. That's all there is. Okay, any questions? Alright, how do you think we're going to find the max? Same thing? Same but different? All you got to do is, for the max, I'm going to do the same thing. So I'm going to say if count is equal to 1, I'm going to say max is equal to num. So I'm making it equal to the 10 initially, right? So if I have these 10 numbers, actually max will be that from the beginning. And then I'm going to go in here and max. I'm going to say if any of these numbers is bigger than my max, then my max is equal to that number. So I make max equal to this initially. Then I say, all right, is this number bigger than max? Nope. Is this number bigger than max? Nope. How about this one? Nope. So it's got to be this. It stays as what it was initially. It doesn't even change. Okay? And let's see it. All right, so this is the largest value is, run it again. So I'm going to do 10, 1, 3, 4, negative 999. Oops, the largest value is max. My bad. That's what happens when you copy paste things. So 10, 1, 3, 4, negative 999. There you go, largest value is 10. Well, I'm not convinced. Maybe it only worked because it was the first value. Let me mess with it. I'm going to run it again. I'm going to put the 10 in the middle. So I'm going to do 1, 3, 10, 4. Negative 999. Still found it. Okay, let me try to mess with it some more. I'm going to run it, put the 10 at the end. All right, 1, 3, 4, 10. Negative 999. Still works. Okay? And this is what you have to do when you do these programs. Don't just assume, oh wait, it worked this way, so it must work for all the other ones. No, test the numbers in different orders. So run your program multiple times. And that's why I want you to do a whole bunch of tests and include all this on the bottom of your code. Okay? Any questions? Going once, going twice. We're sure? I'll take your word for it. Okay, so we learned about loops. We learned some, more advanced things that we do with loops. I showed you how to do the sum, how to do the average. Then I showed you how you can throw an if in there to break the loop for a certain number. I showed you how to do input validation. Right? Where was that thing? Input validation was this piece here when you do a try and except. Okay? I showed you nested loops. Right? You can have a loop inside of another loop, but for now, ignore that for a little bit until we get to the, until you get comfortable with loops. Okay? And that's about all I can tell you. So let's have a look at what you have to do for today. So I'm going to turn off this piece of code because I don't want to see it again. And let's have a look at what you have for today. So you have number 1, P15, a conversion table. What's the conversion table? You're going to have kilograms on one side and pounds on the other side. All right? Let me give you an example. So let's say you want to do a conversion. Give me some currency. So what's a $1 is what? Come on, look. Give me some currency. What is it? Nah, that's not it. They're almost equal. Yeah, they're almost equal. Let's do the euro. Hold on. Dollar to euro. Well, so $1 is 0.89 euro. All right. $1 is equal to 0.89 euro. Okay? What I want to do is I want to see a table or two columns. I want to see dollars on the left, euros on the right. Right? So I'm going to go, all right, I'm going to make up a variable dollar, and I'm going to make it in range. Let's say I want to go from 1 to 100, but I'm going to go in steps of 10. Okay? I don't want to go see every one of them. I want to see every 10th. What is it? So I'm going to go in here. I'm going to say, okay, first I'm going to put the label. Oh, let's do it this way. So first I'm going to say print dollar equals dollar. And that should be your first step. That's what you were doing, right? So the first thing you want to do is just see if the value of the dollar is really changing to what I want it. So it should go 1, 10, 20, right? Run it. Or whatever, 1, 11, 21, 31. Maybe I should go at 0. Let's go at 0. $0. That doesn't make any sense. All right, whatever. 11. 11 is good, just as good as any number. All right, so 1, 11, 21. So these are my dollars. Okay? And then how am I going to calculate my euro? I'm going to go in there. I'm going to say, all right, well, I already said that $1 is 0.89 euro. So I'm just going to say, okay, here, the euro, oops, label euro is equal to dollar times 0.89, right? Make sense? Run it. Hope for the best. All right. So, and one issue is I don't like this many decimals. How do I round it? Well, we do the percent 0.2f. Maybe I want to do 1 decimal. Percent, pull out 2f, 2 decimals. All right, get rid of the comma, make this a percent, put parentheses around the formula, run this again. And these are the values, right? 1 euro is $1 is 0.89 euro, etc., etc., etc. Okay, so it works. Kind of. I don't want to see dollar every time. What I want to do is I want to see the label on top, and then I want to see the label for the euro on top also. So I'm going to take these out. I'm going to take this out from here, and I'm going to leave this here just the percent %f with maybe a little space. And on top of this, I'm just going to say print dollar space euro, and hopefully it's lined up. We'll find out in a second. Run it. It's a little crooked. Maybe I can put a little extra spaces here. Run again. Okay. So maybe I should push it a little farther. Let's go to 110 so you can see how it messes up with something else. Okay. So I rounded up. I rounded this to 2 decimals, which is great. But notice how the column gets shifted. So when I have $1 here, and then when I go to 11, this one gets shifted, right? So there's a little shift to the right, and it's because you go from 1 digit to 2 digits, right? And then you're forced to shift this. Then the same thing happens when you go from 2 digits to 3 digits. This thing here gets shifted, right? A little bit. So how am I going to prevent this shift? I'm going to go in there and I'm going to tell it reserve 3 digits for this first column. So wherever the dollar goes, I'm going to put a quote percent, and I'm going to tell it, okay, reserve 3%, 3i. So reserve 3 spaces for an integer, which is the dollar for this place right here. Okay, let's see it. Now it's lined up, right? No longer a shift because it's now I told it reserve always 3 places no matter what, even if it's a single digit. Normally, if you do it the way I did, it right aligns it, but you can go and do a minus in there. I think that's where the minus goes. And then it's going to be left aligned. It will still preserve the space. It will still reserve 3 spaces for this column, but now it shifts it to the left. Okay? Questions? We're good? All right. So that's the example of P15. So this is your P15 hint. All right. Let's have a look at P16. And tuition table. Okay?
Excuse me?
Yes, sir.
Can I look at that code one more time?
Yep. What's up?
How do you put in commas every, for 1,000 if you 1, 0, 0? Can you do that?
What do you mean? Oh, you mean like the separator? Okay, the separator is if you go back to your, if you go to week 1, and you look at output, this %f, %i, %s, I think it should be in there. Right here on the bottom. This piece right here. So the question is, how do I get, if I have a really, really big number, how do I show that number like a million with the every 10 or every 3 digits separated by comma? right? It's right here. You do these curly brackets, colon, and then a comma in there, and then format. And there's the example right here of how you format this gigantic number into this thing using that. Okay, so just copy paste it, look, and run the program so you can see how it works. Okay?
Thank you.
Yep. All right, so let's go back to this where I was. Okay, so a tuition table is similar to that previous thing that I had, except you're going to have this piece increase by a certain value every time. Okay? Any ideas on how to do this? Let me show you. So let's say I want to, I don't know. Let's say I have a person gains 10 pounds. Let's make it 5.5 pounds. Or no, let's do this. A person gains 5%. No, let's do 3% weight in 10 years. Right? Starting weight is, I don't know, 150 pounds. Right? They just had chemotherapy. So what we're going to do is, we're going to do, all right, weight is equal to 150, right? And then I'm going to have, I have this thing happening for 10 years. Again, a for loop. If I know how many times this thing happens, I do a for loop for, I don't know, year, makes a good sense, in range from 0 to 10, increments of 1. Let me check if my years are working first. Year equals year. Run it. Should have turned off that other code. There you go. It goes from 0 to 9. Man, maybe I want to go from 1 to 10. Let me turn off this code here. Okay. So I want to, how do I change this thing to go from, instead of 0 to 9, I want it to go from 1 to 10. How do I change this? I'm going to start it at 1. Let's just check. And when in doubt, just make little changes to your code, run the program, see what happens. Okay, I changed this first piece to 1. Is that going to do it? Run the program. It goes from 1 to 9. Now, okay, it started at 1, but I want it to go to 10. How do I make it go to 10?
We changed the 10 to 11.
Excellent. We changed the 10 to 11. Run it. I got my years right. 1 to 10. And again, this is the procedure. Whenever I'm going to write some kind of a loop, I'm not going to assume the loop works. I never assume anything. I'm just going to write the loop, check to see if it works. Okay, if my loop works, it goes from 1 to 10, then I can move on to the next piece. All right, the next piece is, I said, I'm going to show you the weight. So I'm going to say, all right, weight equals, and I'm going to put the weight in there, and let's go the percent point, I don't know, 1F. I want to round it to 1 decimal. I'm going to do a percent in there. Okay, run the program, see what happens, baby steps. It's still 150, right? And I can go in there and mess this thing up, change it a little bit. So I don't want to, I don't want the shift, so I'd say I'm going to go percent 2i, right? Because there's going to be 2 digits for that year, so it doesn't shift. Run it again. Goes from 1 to 10. It's not crooked like before when you get to 2 digits from 1 digit. Okay? But my weight's not changing. How am I going to change my weight? Any ideas? Remember that accumulation business? I'm going to say weight is equal to its old value plus what? I said 3%, right? How do I do that?
Weight times 0.03.
Excellent. 0.03, that's 3%. Well, you can do 3 divided by 100, whatever you like. Let's go 0.03, right? 3% increase, right? So increase the weight by plus 3% every year, right? Then when I run this thing, there you go. So in 10 years, you go from 150 to 195. Any questions? Make sense? All right. And again, this is an example of accumulation again. So that's your hint for number 16. Let's go turn this code off now and have a look at the last one. All right, number 17, sum of positive and negative numbers. All right, I'll show you how to do the sum of negative numbers. Okay, so let's say I want to P17 hint, right? I want to find the sum of only the negative numbers entered by the user. Okay, and write a program that reads X in whole numbers and outputs the sum of positive. The user can enter X numbers in any difference. So this is your sample run. So how many numbers would you like to enter? Let's say 4, right? And then they enter 4 numbers. So we already did this one time, but let's do it again. So, all right, we're going to say, all right, many is equal to int input. How many numbers would you like to enter? And then I'm going to say, all right, for I in range from 0 to many in increments of 1. Let's check the loop, because again, I never want to assume something works. I'm going to do print I equals, and let's test it. So I want to enter 3 numbers. This loop should happen 3 times. Okay, good. Maybe I can change this thing to, I want to go from 1 to many plus 1, right? So that I starts at 1. How many numbers would you like to enter? I want to enter 3 numbers. 1, 2, 3. Okay, now what I want to do is I also want to insert this value of I inside my input. So instead of doing a print, now what I'm going to do is I'm going to say, all right, int input, and I'm going to say, please enter value number this. Okay? Now let's say this is going to be some number that they enter. Okay? Is this going to work? Yes or no?
We don't know yet.
You don't know yet, but give me a guess. Yes or no? Is it going to work? No. Good guess. Let's try it. Whoops. Forgot my unexpected EOF while parsing. It means you forgot this. Run it again. That's not what I meant, that it's not going to work, but let's watch. So 3 numbers. Oops. Input expected at most 3 arguments got 3. Remember, I told you that you can't use the little commas when you're doing input. It works fine when you have a print, right? When you have a print, you can have commas, no problem. But when you have an input, you can use commas. So easy fix is you just say plus str, turn this thing into a string. Whoops, I. And then this one is going to be another plus. So what am I doing? I'm doing string concatenation. I have one string, and then another string, and then a third string. When I concatenate 3 strings together, it becomes 1 string. So that should satisfy this thing here where it says, I'm expecting 1 thing, but you got 3. All right? You're going to learn what arguments are when we get to functions. Okay? So let's see if this works the way it is. Run it. So would you like to, how many numbers? 3 numbers. Okay, please enter number 1. 1, 2, 3. So that piece works too. And again, incremental baby steps. Notice how many times I had to test my program. Never write the whole thing and hoping it's going to work for you. Write 2 lines of code, test it. Does it work? Yeah. Okay, now add a little more to it. Test again. Does it work? Yeah. Okay, now move on. So far so good. I want to find the sum of only the negative numbers, right? All right. So if I had sum, right, then I would just be doing sum plus equals num, right? And then I can show you print sum equals sum. Alright, so I want 3 numbers, 1, 2, 3. Okay, that's great. But what if I had something like this? I have 4 numbers, and I have 1, -1, or -1, 2, -2. Alright, sum is 0, but I don't want just the sum. I want, on top of the sum, I want to figure out what's the sum of just the negative numbers. So I'm going to make a variable, sum, let's call it sum neg. It's also going to start at 0. Right. Whenever you're counting something, whenever you're adding up a bunch of things, whenever you're doing accumulation, start at 0. Okay? Most of the time, unless there's some special case or whatever. So how am I going to make sure that a number is negative? How do I know that a number is negative? What do I do? If what? If num is less than 0. Excellent. Right? If num is less than 0, I'm going to say sum neg plus equals num. So only add the negative numbers in here. So let's check again. Print sum neg equals sum neg. Run again. And I'm going to do the same thing as before. I'm going to go, all right, I want 4 numbers, 1 minus, whoops, all right, minus 2. Let's do 2. And then I'm going to do a -1 at the end. So the sum of all the numbers is 0. Sum of only the negative numbers is a -3. Make sense? Any questions? Going once, going twice. All right, I believe you. So what I'm going to do is I'm going to save this. I'm going to upload it for you. Remember, don't try to type up as I'm going because I go fast and I'm taking notes for you anyway. All right, so just pay attention to what I'm doing. Question?
Can you unlock the codes that you run so that way it's easier to look into it?
You want me to turn off all these? All right,
Yes, please.
fine.
To see it's all green, it's really hard to.
All right, I'll turn them off. All right, there you go. Nobody's ever asked that, by the way, so no problem.
I have a question.
Yes, sir.
How do you know like whether to use single quotes or double quotes?
Makes no difference. Whether you use a single or double quotes, Python doesn't care.
Alright.
It's the same exact thing. Other languages would care. In other languages, single quotes means it's a single character. Double quotes means it's a sentence or a string. But Python can't tell the difference between a string and a character. It's all the same to it. So yeah, it doesn't matter what you use. Just make sure it's consistent. If you open it up with single quotes, close it with single quotes. If you open it with double quotes, close it with double quotes. And you could do the same thing with multi-line comments. So for example, see this piece of code here that has 3 single quotes? I can go in there and I can say, all right, double, double, double. And I can just change this here to double, double, double. Same thing. Doesn't care. Okay? Good question. So let me turn that off too. Enable this piece of code. Whoops. That's good. This also. Yeah, and if you want me to do that in the future, just remind me. I'm happy to oblige. Yeah, I've thought about this before, but nobody's ever asked me to do it. And I'm almost done. And again, I'm going to have to test it one more time now just to make sure it works. There's no screw-ups. All right, enter an age between 0 and 123. 12. No, yeah, 12. How many? 4. All right. 1, 2 times. There you go. 1, -999. -999. We probably had the same loop twice. There you go. Enter any number to quit. Number. How many numbers do you want to enter? 2, 1, 2. There's your nested loop. 5, 4, 2, 3. And there's your examples. This is 3 numbers, 1, 2, 3. There you go. So thank you for asking me to do this. Now I can copy all this so you can see what it looks like when the whole thing works. And it goes all the way to there. All right, I'm going to go all the way to the bottom and show you how my code ran. Don't forget, every program you turn in has to have, show me how the program tested. And on top, all right, comments. So name, date, what's the date? 14, 6, 14. All right, what is it? Description. Description is examples of loops, also known as repetition. And you also would have your program number, but this doesn't have a number. Program number, I don't know, P0, PY, okay?
What about the Python version?
What do you mean, Python version?
Like Python 3.5.2?
Oh yeah, there you go, Python version, good point. You also want to tell me which Python version you're using. So version, and it tells you right here the version 3.44, that's what I'm using, 3.44, and that's it. Okay, save it, and I'll upload it for you. If you don't have any other questions, let me just stop this recording, or I'll just unplug it later. Okay, so that is all I have, and yeah, you're welcome. Question?
Are we going to go for P18 at all?
P18?
The penny or $1 million?
Penny or $1 million is similar to what we did. You're basically asked the question, if you have a choice between, let me go to the next one. So the next one is penny or $1 million. I didn't realize there was another one. But this basically uses all these things that we've done so far, and you're given this. So you have a choice between a penny, which doubles its value over 30 days, or $1 million. Which one would you choose? So at day 30, either penny or $1 million. Which one do you think you would make you more money? Penny, huh? How much do you think a penny is at day 30? It sounds ridiculous, right? How can a penny be more than $1 million in 30 days? Compounding. Right? So day 1 is 1, then it's 2, then it's 4, then it's 8. Right? At day 30, it's actually $5 million something dollars.